Look beneath the rooftops of the world, through all the lands, into the houses of healing. Within the past 100 years, we have taken an upward road. Where once was despair, today there is knowledge, skill, and healing. Here the walls echo with the great names of healing: Pasteur, Ehrlich, Lister, Curie. Consider the disease. Then in Toronto, Banting and Best found the treatment: insulin. Tetanus. Yesterday, tetanus killed. Then the Japanese Kitasato found the answer. Pernicious anemia, death once. From Boston came the discoveries of Minot, Murphy, and Whipple. With such great victories behind it, science turns to the most fearsome disease still threatening man.
Probably macerated a bit in preparation.
Done a few days ago. Malignant. Let's blow the cheek code.
Occlusion body stained well, Ross?
Yes.
3 men concentrating on a lantern slide, a photograph of human tissue.
Yeah, all right. Oh. Mr. Davis, come in, won't you?
Thank you.
How do you feel today?
Very well, thank you.
That's fine. Some of my colleagues would like to have a look at you. Now, this is Dr. McVicker and Dr. Rome.
Matter of fact, we've just been having a look at a slide of your specimen.
These gentlemen are research scientists.
Yes.
Oh, will you put your hat and coat on the chair, please? Thank you.
Here is a man whose body is being undermined by a strange disturbance. This body, what is it? How did it begin? It begins with a fertilized human egg, a single pinpoint fragment of life, the cell. In this cell lies the power to grow. This it does by dividing, first into 2, two into 4, mitosis, the biologist calls it, a fundamental process of life, into 8, 16, and so on, growing into a predetermined form, growing into the human embryo. As the embryo matures, the cells develop into special structures. By the 7th week, the embryo is composed of many millions of cells, grouped according to their function into developing tissues and organs. Some make up the tissues of the hand. Others, those of the eye. Still others from the fetal heart to the adult heart. And from the embryo finally emerges the complete adult man. And the adult man is an organization of billions, trillions of cells, forming the systems by which he can live work and reproduce. Muscles, bones. A delicate network of blood vessels, the veins, the arteries. Tireless muscles of the heart, the food-absorbing villi of the intestine, the sugar-storing cells of the liver. Into these and many more, as intricate and marvelous, grow the cells. The man is balanced, living, complete. His body has reached an invisible boundary line, and the cells stop growing. But sometimes they don't. Sometimes something happens to stop them growing again. Uncontrolled, outlawed, dividing again, indifferent to the laws and life of the body of which they are a part. They grow and grow, beyond all normality, pressing on healthy tissues, healthy organs, growing, spreading throughout the body to start new malignant colonies, growing without purpose, disrupting the vital functions of the body. This is cancer.
Very interesting example.
One of the most curable of all cancers.
No pain at all, Mr. Davis?
No. Mr. Davis is one of the lucky ones. 90 chances out of 100 will cure it. Thank you, Mr. Davis. It's very gratifying to know if you can. Your treatments will begin immediately, Mr. Davis. Okay, Doctor. Thank you. You don't worry now. No. You chaps going back to the lab?
Yes, I have to.
Thanks for coming in. Right.
Goodbye, Ross.
Goodbye, Rom.
Why should the cancer problem be so difficult? It's a matter of a cell that won't stop growing. We know that. Why not? Why can't we find the reason? The world's best minds, backed by millions in research funds, are at work on the problem. Why is it taking so long? Why is the answer so difficult? It is long and it is difficult because this tiny cell, this microscopic unit of life, is a very world in itself, a universe to be explored. Science is piercing deep into this universe, in its micron miles detecting constellations, charting them, naming them. The centrosome, the mitochondria, the Golgi network, the cytoplasm, the nucleus, heart of the cell, the chromosomes, the nucleolus, decades to chart this minutest funnel. These quivering worlds are spaced out within one single cell. Yet this is only one among the billions which make up the human body. Here in this pinpoint universe lies the mystery of life and the riddle of cancer. Alive in this flask is a tiny bit of flesh. The beat of time brings a pause to all living creatures. The span of life is measured out. 3 years, 70. But a bit of flesh taken from this animal can be kept living, growing, alive. Work with bits of living animal tissue is fundamental today in the field of cancer investigation. For his experiments, the scientist can grow normal tissue as well as abnormal. In many instances, cancer cells have been grown in glass without losing their destructive, malignant qualities. Transferred to a suitable animal, they would kill it. But these bits of tissue, no longer able to draw upon the body itself for life, must be nurtured and nourished with exacting technique. The conditions under which they will live demand skillful control. Even their feeding must be conducted in sterile chambers. And they must be fed regularly with life-giving solution. In this way, both healthy and cancerous tissue, whichever is needed for experiments, can be maintained. Tissue can be grown, cultured in eggs also, again under controlled conditions. The cancer cells are injected into a fertilized egg. Here they grow, taking their nourishment from the chick embryo. And cancer tissue can also be grown in laboratory animals. Tools and techniques for this work may appear simple, but they have taken years to develop. Hundreds of samples, thousands of hours. In many ways, laboratory workers find it useful to experiment with tissue that has been removed from the body. What effect will various chemicals have? How will the tissue react to changes in diet? Questions about differences between normal and cancer tissue. The rate of growth can be measured and recorded stage by stage, like the growth rings of a tree. Inside each cell that makes up this living and growing mass lies the challenge and the answer. Within each cell are the nucleus and the centrosome. Locked inside the nucleus lie the tiny elements which control heredity. These are the chromosomes which will bestow the characteristics of the parent cell upon the daughter cell when the final birth crisis comes, when the astral body divides in the quiver of creation. When the interlocking chromosomes part, separating, one has become two, sharing a common inheritance. What part does heredity play in cancer?
I don't know what you think of when you think of a hero, Kay, but you're looking at one right now, the most important factor in our experiments.
Sure killed mouse.
This mouse is pretty special. We can learn a lot of things from him and the other mice in my lab down the hall. For example, why you've got to be so much like your mother.
These newborn mice have a family tree that cannot happen among humans.
Baby mice.
Brothers have been mated to sisters, generation after generation, until the family characteristics of each mouse are almost completely predictable. These mice will have cancer. 90% of their offspring will also have cancer, and 90% of theirs.
Here, Kay, take a look at this one. No, come on.
However, a mouse can be bred which will have very little chance of ever developing cancer. But men are not mice.
Well, let's get things straightened up here now.
Between one human generation and the next, there is no precisely known relationship in cancer.
Okay.
I think you will, Joe.
For the inquiring mind, the study of genetics is a journey along the entire scale of life. A journey from the amoeba to the guinea pig, from mice to possible applications in man. When science can say with complete assurance what part genetic factors play in cancer in humans, we shall have come to a peak of discovery. To learn from mice, the scientist must study them for years, but only a few weeks are required to follow the entire lifespan of the Drosophila, the common fruit fly. In 10 months, the scientist can observe almost 30 generations. He has searched into the mechanics of heredity and found that chromosomes, the carriers of heredity, can be changed by forces outside the cell. The normal fly can be placed under a bombardment of X-rays. These X-rays strike like a kind of electric hammer. This can change the chromosomes so deeply that following generations may produce new and different variations. Mutants, creatures with shriveled wings, freaks. And these can occur in many animal species, in mice, for example, somersaulters, circlers, and what is more, the new characteristics of these animals may be passed on from generation to generation. Is cancer due to something that changes the chromosomes of a normal cell? The world of the cell is like a complex industrial organism, carrying on all the interlocking functions necessary to life and growth. It breathes. It feeds. It transports. Combines. It divides. Converts. Manufactures. Life. Life and growth. Do the life functions of the normal cell differ from those in the cancer cell? If we knew, could we disrupt the cancer cell's machinery? In these glass containers are bits of cancer tissue taken from a rat. Here, with this apparatus, the scientist learns about the breathing of tumor cells, the gases they take in, those they give off. It is part of the great investigation carried on in laboratories all over the world. The investigation into the life processes of living cells, normal cells and cancer cells. There we are. Tea when you're ready, Barbara.
You seen Reed's article in the new journal, the tracer technique one?
Yeah, I looked at it over the weekend. Nice bit of research.
Yeah, he's a good man. I'd still like to see more evidence, of course.
Murray, I have been hearing of the, Cellular
What? Avancement. Progress.
Oh, what a progress in the work.
Results are just starting to get exciting now. Starting to pay off, eh? About time, too. Took nearly a year to get set up. And I think we've got some.
It's interesting to speculate what it means if he's right. A lot of theories will go.
Please, 10 new questions for everyone.
That's good to hear. How's your grant holding out? Well, we've been pretty lucky that way. They understand the long-range nature of the problem. Say, I got a letter from Carlisle this morning.
I'm telling you.
Oh, yes, he's published his paper now. Look, this tea. Barbara, are you breaking for lunch?
In a minute.
He'll be here in a minute. So, I hope you have. You've worked hard enough.
Patience, time, persistence. There is no royal road to facts, to knowledge, to understanding. No royal road to easy answers. No easy answers to great and baffling questions. Can something from outside the body invade the cell to change its behavior? What is there in our environment that may affect the cell? We are beginning to understand the exact relationship between the world around us and the occurrence of cancer. Investigators, carefully following up known cases, are searching for the pieces of a puzzle, pursuing a clue. We have learned, for example, that people who spend a lifetime of exposure outdoors, constantly under the sun's rays, are more apt to develop skin cancer than indoor workers. But there are certain exceptions. Why? When we find enough clues, we can begin to plan means of prevention. We need facts, statistical studies we can analyze, compare.
Mrs. Jones, have any of these members of your family cancer of the breast? Yes. And how many pregnancies have you had?
Every promising line of inquiry is being followed. Family patterns, job history. Will 1,000 cases point to a common factor? Statistics. Changing technology, exposure to new chemicals. Are certain cancers more common among people in particular industries? Is there a tendency to be observed? Statistics, throwing light on the mystery. Are certain cancers more common to men than to women? Statistics, facts to be studied. Is there something in our daily work that starts it off? Science is examining every known suspect, samples collected from 100 places, breaking them down in an attempt to find the deadly factor. Research has advanced far since that year of 1918 when Japanese scientists produced a tumor on the ear of a rabbit by painting it with tar. Since then, scientists have found hundreds of compounds that can start cancers, put together models of their molecular structures.
How's it coming anyway?
Well, we isolated an active fraction. Should look something like this. This is your hydroxyl group. We're not too sure about the amino group. Probably here. Yeah. You seen Taylor's...
Applied to our daily work, such research can test the effects of the chemicals we use, perhaps help to prevent cancer. But for science, there are still the questions. How and why does the chemical start cancer? What does it do to the cell? Questions to be answered, and the answers are coming. And because of this constant search and research, a man can approach the thought of treatment with confidence. There is much that can be done now that was impossible even a few years ago. Each day we make some progress. In the unseen laboratories behind hospital walls, scientists are working with the sensitive tools that may lead to additional weapons for healing. The exploration of known and new fields continues. There is radium therapy, the patient work that has produced and refined it. Little tubes, milligrams of radium applied near the cancer growth. Radium dosage, size and strength still being minutely studied. There are radioactive isotopes. atomic energy turned to the uses of man. Some cancers, of the thyroid gland, for example, have shown signs of yielding to this new technique. There is the Geiger counter itself. Its electric crackle, a yardstick to measure and follow radioactive compounds within the body. Radioactive iodine, carbon, sodium, phosphorus. It is against this background of research that the patient with cancer is being treated. In the field of X-ray therapy, multi-million voltage weapons for producing more effective and more penetrating radiation are being developed.
David, I'm just going to position this machine and bring the comb right down till it's resting on your cheek. Now you tell me if this is too tight, Mr. Davis.
Yes, all right, come on.
Mr. Davis will be cured. But not all are as lucky as Mr. Davis. There are those with cancers which, unlike his, give few warning signs. There may be no pain in the beginning. They lie hidden in the body. And again, with the great advances in surgical techniques, the outlook is good. The majority of cases brought to medical care this year can be effectively treated. But it must be found soon enough. That is why science is searching for a test, a reliable test that will find cancer early, while it still can be cured.
Leaving right away. Kids in bed? He did. Oh, well, put a Band-Aid on it. He'll be all right in the morning. What bill? I paid that bill at the beginning of the month, sure.
From his first lesson in kindergarten, it takes perhaps 20 years of study to make a scientist.
The Jones? No, I don't want to go there. Tell him we can't go. We've been out...
He is a man like other men, but also he is a man whose intelligence has been alerted, his imagination given special edge. He has stored within him a vast fund of knowledge drawn from the scientific harvest of the world. And in him is the agitation of a problem.
He did? Oh.
The search, the question mark.
See you in half an hour. Yeah, bye.
There are men like this in places like this, in Montreal and Washington, New York and Paris, London, Rome, Geneva, Stockholm. What is man that thou art mindful of him? Here a challenge lies. And here a challenge has been accepted. The steady, unheroic search for a shaft of light. And the light may come from any work, from the study of an animal or a plant root, for cancer is common to almost all living things. And on this bench, on that one, in this lab and that, the search goes on, the search for an answer. Each passing day, progress. The pursuit of an idea, the exchange of new knowledge all over the world. Who is to say when the answer will finally come? It is the answer to life for which the students of science are searching, and the problem is great. But we are surrounding it, closing in on it. More and more new minds, highly trained and training others, equipped with every skill and technique of the 20th century, are applying themselves to the work. The answer will come from the effort of many men and women, the doctor, the nurse, the chemist, the biologist, the physicist, the mathematician. All these and more advance in the dedicated search. Behind them will be the victories of other scientists. And when the answer does come, finally, they will have ventured far along the corridor of the universe.
We come again this morning to our discussion of the cell. We continue to turn to it, inevitably. Doing so, I would ask you to bear in mind that we're dealing here with an enormous problem, the problem of life itself. Can we have the projection, please? It is on this, on the cell, and the mysteries it holds, that science today converges.